Hello everyone, welcome back in this video lecture series on refrigeration and air conditioning. I am Mayank Kushwaha from ABS Engineering College, Ghaziabad. In this video, we are going to discuss some numericals based on refrigeration system, which have been previously asked in AKTU and semester examination. So the first question that I have brought here is this, which was there in AKTU 2324 event cell. And the question says that an inventor claims to have developed a refrigerator working between 1000 degrees Celsius to 500 degrees Celsius. His refrigerator extracts 2200 kilojoule heat from sink and consumes 40 kilojoule of work. Justify the claim of the inventor. So let us first note down the given data. According to this, the higher temperature is 1000 degrees Celsius, which is equivalent to 1273 Kelvin. And the lower temperature, Tc, is 500 degrees Celsius, which is equals to 773 Kelvin. He also claims that absorbed amount of heat is 200 kilojoule, whereas the work required by the refrigerator is 40 kilojoule. So if we try to draw a diagram for this, then it would look like this. I'm sure you are able to recall this diagram from lecture 2. Right? So to solve such type of problems, we can compare the COP of a refrigerator system in actual scenario and the COP of the same system when it is working on reverse Carnot cycle. So let us try to first calculate actual COP. So COP of the refrigerator in actual scenario is equal to actual amount of heat absorbed, which is nothing but a refrigerating effect, divided by work input. So we know that this is QA, amount of heat absorbed from the lower temperature body, to W supplied. So from the given data, it is equal to 200 divided by 40. So from this thing, we can calculate the actual COP of this system is turning out to be 5. Now, if the same system works on reverse Carnot cycle, so COP of the same refrigerator when it is working on Carnot would be equal to cooler temperature divided by TH minus TC. So this value will be equal to 773 divided by 1273 minus 773, which would be equal to 773 divided by 500. So if I divide it, then I would get 1.546. So from these two things, we can compare that the actual COP is coming out to be Carnot COP of the refrigeration system, which is not possible. Why it is not possible? We have already discussed that the maximum possible efficiency or COP of a system which can be achieved is of Carnot. And here the inventor claims that his COP is far better than Carnot's cycle. So we are going to say that it is not possible, or the claim by the inventor is not justified. Right? So in this way, such type of numericals can be solved. I hope it was a pretty easy one. The next question, which we are going to talk about, is this one. This question is taken from, again, 23-24 ODSAM. The question says that a cold storage is to be maintained at -5 degrees Celsius, while the surrounding are at 35 degrees Celsius. The heat leakage from the surrounding into cold storage is estimated to be 29 kilowatt. The actual COP of refrigeration plant is 1/3 of an ideal plant working between same temperature. I think it should be same temperatures. Right? Find the power required to drive the plant. So one more time, we are going to draw the same type of system. TH, refrigerator, TC, QA, QRW. And to note down the given data, TC from the question is -5 degrees Celsius, which will be equivalent to 268 Kelvin. TH would be 35 degrees Celsius, which would be 308 Kelvin. Right? The next thing which is given to us is QA, which is 29 kilowatt. Other thing which is given to us is COP actual is 1/3 of ideal COP, which is nothing but COP of a Carnot system. And we are supposed to calculate power required. W is supposed to be calculated. Okay, so let us move forward and try to solve it. So we know that COP of a refrigeration system working on Carnot cycle can be done as TC divided by TH minus TC. So this will be equal to 268 divided by 308 minus 268. So if I calculate this value, I will get 268 divided by 40. And the value turned out to be 6.7. So the ideal COP Carnot is 6.7. So the actual COP as given by the numerical would be 1/3 of 6.7. So that would be 2.33. 2.23, right? We also know that the actual COP can be given as amount of heat absorbed divided by work required. So 2.23, as we have calculated here, would be equal to Q absorbed, which was 29 kilowatt, 29 kilowatt divided by W. So work required will be equal to 29 divided by 2.23. So the value turned out to be 13 kilowatt. So which means the refrigerator requires 13 kilowatt of work to pump out this heat, 29 kilowatt, which is leaking into the cold storage system. Okay. So again, it seems to be a pretty easy one, numerical. So this is basically the level of the questions that I have been asked in AKTU and semester examination. So it would be pretty easy to solve such type of numericals if you practice a little bit more. Okay. Some of the references. Thank you, everyone.